Here's problem 1319. A spaceship of mass m circles a planet, mass big M, in an orbit of radius r. How much energy is required to transfer the spaceship to a circular orbit of radius 3r? So we have some kind of planet, mass m, and we have a spaceship traveling around in a orbit of radius r, and that spaceship has a mass little m, and we want to transfer to a larger orbit of radius 3r. Now in either case, this mass m is in a stable orbit, and we know from our theory that the energy of a stable orbit is equal to negative g times the mass of the planet times the mass of the satellite over the radius of the 2 times the radius of the orbit. That is for a stable orbit based on its kinetic and potential energy. So in this case, our initial energy is going to equal negative g, mass of the planet, mass of the satellite, over 2 times its original radius of the orbit, which we're going to call big R. And that will be our initial energy. Our final energy is going to be negative g, mass of the planet, mass of the satellite, over 2 times its new radius, which is actually going to be 3 times big R. So that's going to be a negative g m over 6r. It's actually a greater energy, so our change in energy, which will be our final energy minus our initial energy, and that will be the energy that we have to add in order to get to that final state, will be equal to negative g big M little m over 6r minus our initial energy, which is a negative g big M little m over 2r. So this is g m over r times a negative 1/6 plus 1/2, because a negative negative will give you a positive. So we'll have a negative 1/6 plus 1/2. That's going to be a negative 1/6 plus 3/6 times g big M little m over r. And so that'll be 2/6, which would be 1/3. So this is going to be equal g big M little m over 1/3, which would be 3 times r. That's the change in energy. That's the energy that we need to add to go from our initial orbit to our final orbit, where both of the orbits are stable orbits.